Hi, welcome to today's lesson. What I'm going to be looking at today is how to solve the quadratic equations using completing the square. Okay, so solving quads using completing the square. Okay, alrighty. Now, if they ask you to solve a quadratic using completing the square, you have to show this working. Okay, you can't just plug things into the quadratic formula because they won't give you the marks for it. They want to see that you understand the working to get from the ax squared plus bx plus c version into the solution using completing the square. Okay, so let's take a look at an example. The steps I've got on the notes, so you can follow them 1, 2, 3, 4, but I'm just going to go through them very quickly. Okay, so e.g. x squared plus 10x plus 1 equals 0. Alrighty, so first things first is I'm going to complete the square on the x parts. So I'm going to complete the square on that part, right? So to complete the square on that part, it's x, same sign, plus half of that, 5, all squared, minus half of that squared, to correct for it, minus 25. Okay, so that's the x part, plus 1 equals 0. Everyone with me? Okie dokie. So let's just tidy this up. Negative 25 plus 1. So I've got the x parts, x plus 5 squared. Negative 25 plus 1 is negative 24 equals 0. Okay. Now this is where I stray slightly from my rule of keeping everything on this side when I'm solving quadratics. Okay. This is the one time where I think it's better to take anything that's not the square into that side and start working on OTOS. Okay. Using bit mass backwards, and opposite to other side. So if I use bit mass backwards, the first thing I'm going to get rid of is minus 24. So I've got x plus 5 squared equals opposite of minus 24 is plus 24. Alrighty? Now, bit mass backwards. I can't get rid of the plus 5 because it's inside the brackets. So I'm going to get rid of the indice, bit mass. So the I before the brackets. So I'm going to go x plus 5 equals the square root of 24. Okay, you with me? Now, I'm going to do two things here. I'm going to quickly look at surds, okay, how to write this as a simplified surd. Alright, so if I'm taking 24, the square root of 24, and I'm writing it into simplified surd form, okay, whenever I'm breaking something up into a surd, into simplifying a surd, I want to write it as the perfect square, if I'm dealing with roots, a perfect square times some other number. Or if I'm dealing with cube roots, a perfect cube times some other number. You could also use products of prime factors, but it's easiest just to do this. So, I'm going to write 24 as the square root of 4 times 6. Okay, 24 is 4 times 6. Okay, 2 times 12, 4 times 6. Okay, and then I'm going to split the square root across the multiplication, which is completely allowable to do. You can split square roots across times and divide. You cannot split them across plus and minus. Okay, just remember that all the time. And then the square root of 4 is 2, square root of 6, well, 6. Okay, square root of 6 is not 6. Listen to me. The square root of 6 just stays root 6. Okay. Now, there's only one thing you must remember. I will always get two solutions when I square root this. There's the positive and the negative. Okay, so I've got positive, you don't have to write the positive there, but I just did, 2 root 6. Okay, or I've got also x plus 5 equals minus 2 root 6. So you must remember every single time you square root, you always get a plus and a minus. Okay, and then I just tidy this up. I've got x equals negative 5, opposite plus 5 is minus 5, plus 2 root 6. And on this side, I've got x equals negative 5, x equals negative 5, minus 2 root 6. Are you with me? Okie dokie. Now, there's two things I wanted to quickly show you here. First thing, squared, I expect two solutions. If I have a quadratic, I expect two solutions. There are certain types of quadratics where you get one solution. There's actually two solutions where the one solution is repeated. Okay? And there are other quadratics where you get no solutions. Now, where I would get no solutions is if I brought this 24 over and that became a negative. Then I would have square root of a negative. There's no such thing as a square root of a negative. while you're in the real numbers, okay? If you suddenly go into the imaginary numbers, then you can talk about it. But let's just stick into real numbers, okay? I can't do the square root of a negative for now. Okay, so I expect two answers, right? In this case, quadratic. The other thing I want to quickly show you is take a look if I had to write out the quadratic formula. Minus 10 plus or minus the square root of b squared minus 4ac over 2 times a is 1. Okay? This is just this. Minus 10 divided by 2, minus 5. If you had to put all of this into here and tidy it up, you get 2 root 6. Okay? Alright. So all that you're doing is you're just going from an ax squared plus bx plus c to the answer that you would get using the quadratic formula anyway, but showing the working instead of just plain substitution. Okay? The plain substitutions to quadratic is easy. The understanding to go from there to there, that's what the question is asking. It's not asking for the answer, it's asking for the understanding. Are you with me? Be careful with that. I see a lot of kids who, well, I have seen a lot of kids in the past who get this, they say using completing the square, they go, oh, I know the completing square is just a quadratic formula, so they just plug it into the quadratic formula. They get the right answer, but then they get 1 mark out of 5 because they haven't bothered to show the working. Are you with me? Okay. Just be careful of that. Let's do a harder one. Alright? So if you watch completing the square with an A and with no A's, or where A is 1 I should say, then you'll know that it gets more challenging when A is not 1. So let's take a look at this one. E.g. Solve for 3x squared minus 5x equals 2. And they say to 2 decimal places. As soon as you see the words 2 decimal places or leave your answer as a surd, you've got to know I'm either doing the quadratic formula or completing the square. Okay. So, let's quickly take this. Now, I'm going to do this slightly different to how I've done it in my notes, okay? Slightly different, just to show you a different option. You can follow the notes, they're pretty straightforward, but just to show you a different option with this. What I'm going to do is I'm going to leave the 2 on that side, alright? And I'm just going to complete the square on this side. Okay, so I'm just going to complete the square on this guy here, and then I'm going to tidy things up. Okay. Firstly, that 3 can't be there, so I have to pull it out. Alright? And then what am I left with? I'm left with x squared minus 5 divided by 3 is 5 over 3. X. Please, please, please don't be tempted to use decimals at this point. Stick with fractions, okay? Because in reality, I would put something like this, because I'm a little bit nasty with test setting, I would put something like this in a non-calculated test, and I'd say, give me the answer in a surd. Alrighty. I know. Aren't you glad you're not in my class? Okay, so there it is, right? So I pulled out the 3, and I've left the 2 there, and I'm just dealing with the x parts. Now I'm going to complete the square on the x part here. So let's leave this 3 floating in the front, okay? And I'm just changing to square brackets, just because I'm going to have round brackets inside here. So, x, same sign, minus half of that. Now, I've left some space here to do some work. Oops. So, here's my pencil working. I'm talking about, I need to half of b. Half, watch my words, of b. Well, 1 times 5 is 5, 2 times 3 is 6. Are you with me? Okay, so exactly as you said with words, so you write it. Okay, half of b, so it's 5 over 6. Okay, close brackets, squared. And I have to correct for when this gets squared. Minus 5 over 6 squared. Just in case, 5 over 6 squared is 5 squared over 6 squared. When I raise a single term, remember division combines terms, when I raise a single term to a power, the power goes to everyone. Okay, just not across plus and minus. Remember plus and minus, the evil children, okay? They don't allow anything to happen. Just times and divide. Wonderful. They let you do whatever you want with powers, okay? So then I can just quickly square both of them, 25 over 36. Are you with me with that? Okay. So I've got this 25 over 36. So that one is 25 over 36. Are you with me still? Still equals 2. Alright. Now I've got 2 options here. And it doesn't really matter. Now this is, if you've watched solving the equations with brackets, I gave you 2 options where you could either distribute out the brackets and then start solving, or you could start straight from bit mass backwards and start solving. Okay. Now, you can do either that. I can either times out this 3 and then start solving, or I can start straight from bit mass backwards BidMass backwards and opposite to the other side, and OTOS, and start solving this from here. Okay, I'm going to do that. All right, I'm going to do that because that might make my working slightly easier down the line. Okay, so the opposite now, I reverse BidMass. I say, okay, what's happening to x here? Well, it's being minus 5, that's in brackets, and then it's being squared, then it's being minus 30, 25 with x, but that's all in brackets, then times by 3. So I've got to get rid of things from the outside in. So I can't touch anything in here because it's happening in brackets. So I reverse BidMass, I get rid of multiplication. Here's multiplication. Opposite times by 3 is divide by 3. Right. So I've got the x here, this bracket. It still looks exactly the same. X minus 5 over 6 squared minus 25 over 36. All right. And then on this side, I've got equals 2, opposite times by 3 is divide by 3, divided by 3. 2/3. You with me still? Okay. So now I reverse BidMass. But now actually, Mr. Roosh, you didn't have to write the brackets in because there's nothing happening outside of the brackets here. So let's take off these big square brackets. Okay. And then let's reverse BidMass again. All right. So I reverse BidMass. Well, I can't touch that because that's in brackets, but I can get rid of this additional subtraction. Okay. So opposite minus 25 over 36 is plus 25 over 36. Okay. What am I doing? I've got x minus 5 over 6 squared, not touching it, are you with me, equals 2/3. Opposite minus 25 over 6 is plus 25 over 6, plus 25 over 36. Everyone's still with me? Okay. Oi, 25 over 36. This is the ugly sum quickly here. Let's just do this guy. Okay. So I'm going to do some more rough working just on the side here. Okay. So I've got 2/3 plus 25 over 36. Okay. Right. Now you know when you're adding fractions, you have to get them to the same denominator. So let's change everything to 36. Okay. So I've got it all over 36. Right. What do I do to 3 to make it over 36? I times it by 12. 3 times 12 is 36. So 2 times 12 is 24 plus 25 over 36. I don't need to change him. So I get that 24 plus 25 is 49 over 36. Okay. Everyone with me? Okay. Go play that again if I lost you there. All right. So let's just tidy this thing up quickly, because the next step I want to be completely at the right spot when I do the next step. Equals 49 over 36. Equals 49 over 36. Now I hope you're all screaming and shouting, going, wow, 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 wow! Look, sir, that's a perfect square, and that's a perfect square. Ah. Yes, you're right, they are. And now, so what I'm going to do is now I'm going to square root the whole thing. Okay, opposite a square, opposite to other side, opposite of square is square root. So let's square root the whole thing. Now when you square root the whole thing, you must remember the positive and the negative. So I've got two options here. I've got x minus 5 over 6 equals the square root of 49 is 7, the square root of 36 is 6. Okay, remember, powers can be spread across divide, so can roots. Roots are just powers, okay, fractional powers. So that's my one option, positive. My other option is the negative option. X minus 5 over 6 equals negative 7 over 6. Are you with me? Okay. Now all that we have to do is we have to tidy things up. Okay. Opposite of minus 5 over 6 is plus 5 over 6. So I've got x equals 5 over 6 plus 7 over 6. X equals 5 plus 7 is 12. Divided by 6 is 2. There's my one answer. You with me? And then my other answer on this side is x equals 5 over 6 minus 7 over 6. 5 minus 7 is negative 2 over 6, which is negative 1/3. So x equals negative 1/3. Okie dokie. Alright, so that's quite challenging actually. You could have solved this by inspection, because these turned out to be very nice, easily come by numbers, not weird surds like the previous one, where something would have been left like that. So you could have solved this by factorizing. But if the question asks you to solve using completing the square, you have to solve using completing the square. You have to show that you know this method of working, okay? As I said before, and I just want to reiterate this, whether I divide here and start straight from BidMass backwards and OTOS here, or whether I multiply out and then get everything to the one side. It doesn't make a difference, okay? Alright, in the notes I multiplied everything out, okay? And then I move things across. Again, if I brought the 2 to this side and incorporated the 2 into this and then distributed the 3 later, it doesn't really make a difference. Okay. There's a lot of order of things that you can be flexible with. So one person might do it one way, another person might do it another way. You need to go and practice some of these and try different ways yourself. Okay. Alright, so trust me on this. Listen, go find some questions where A does not go nicely into B. Okay, where A is not a factor of B. So that when you do take out A, you get an ugly fraction there. And work with your fractions. Don't touch your calculator. Work with your fractions. Get used to working and doing stuff with fractions. You should be okay. By the time you're dealing with this stuff, fractions shouldn't be an issue with you. Okay. Anyway, go watch this again. Go try some more of this. And remember, I'm here for you.